Within this video about the Amazon rainforest, we're going to be looking in particular at how the water and carbon cycles work within the rainforest, how those cycles are being disrupted by human activity, and attempts being made to minimise the damage and disruption to those cycles. If we start by thinking about the characteristics of the rainforest, the Brazilian Amazon shares many characteristics with other rainforests around the world. We find rainforests within the tropics, so located either side of the equator. These areas tend to be very warm and very wet. We can see from the climate graph in the bottom left of the screen that temperatures tend to average around 27 degrees C throughout the year, and rainfall is continuous throughout the year. We have a slightly wetter period of time during sort of January, February, March, slightly drier in July, August, September, but broadly speaking, the rainforests are warm and wet all year round, receiving over 2,000 millimetres of rainfall annually. With specific reference to the Amazon itself, the Amazon is home to around 300 million trees, covering an area of around 5.5 million square kilometres. It's the largest continuous expanse of rainforest on the planet. Estimates suggest that somewhere between 80 and 120 gigatons or billion tonnes of carbon is stored in total within the Amazon rainforest. And because of photosynthesis, the trees within the Amazon absorb somewhere between 1 and 3 billion tonnes of carbon every year. If we look specifically at the water cycle within the rainforest, there are some specific things that apply to the way in which water is moved between stores. The diagram on the left hand side shows you generally how water is moved around the rainforest. There are a few things that it's important to note. So firstly, it's important to consider the amount of fresh water that is being moved around this system. So the Amazon River's discharge is equivalent to about 15% of all of the fresh water being discharged into the oceans every day, just from that one river. So that gives you an indication of the amount of water that we are talking about within this system. Now, one thing that's unusual about the water cycle within the rainforest is that most of that rainfall never actually reaches the ground. Because of the dense canopy of trees and the warm temperatures, the water is very quickly intercepted by the trees, by the canopy, and is then re-evaporated back into the atmosphere. So actually, of all the rainfall that falls, only about 30% of that water actually reaches the ocean. The rest of it is kind of caught up in a closed cycle whereby the water is within the atmosphere, it rains, it's intercepted, and then it's evaporated again. So most of the water is kind of trapped within this system, this loop. We also have obviously other inputs of water, so because of the high temperatures there's also quite a lot of direct evaporation happening either from the surface or from rivers. And there are also very high levels of transpiration, which, if you remember, is the way in which water is returned to the atmosphere by the plants. Again, the carbon cycle in the rainforest shares many similarities with the carbon cycle in other ecosystems. So photosynthesis is absorbing carbon dioxide, and respiration, either from plants and animals, is releasing carbon dioxide. Carbon is lost through runoff into rivers. It's returned to the atmosphere by decomposition. It's added into the soil as a result of the death and decay and decomposition of living material. But again, there are some specific subtleties that we need to be aware of regarding the carbon cycle within the rainforest. One of those is linked a little bit to climate change and the amount of carbon dioxide in our atmosphere increasing. So one thing that's been noted is that as a result of there being more carbon dioxide in the atmosphere, that is leading to increased productivity. So more growth from the plants within the rainforest. That's because the carbon dioxide almost acts as like a fertilizer to spur on the growth of that vegetation. Now, that isn't ideal because although in the short term that's going to offset climate change because it's going to absorb some of the extra emissions, it basically causes the trees within the rainforest to have a bit of a growth spurt, if you like. So they grow quickly and therefore die earlier. So we can think about trees in the rainforest as kind of living fast and dying young. As a result of this extra carbon dioxide, they grow quicker, but then they die more quickly. And what that's doing is actually reducing the capacity of the rainforest to absorb CO2. And it's very concerning that in the future, actually the rainforest might start to become a source of carbon rather than a sink of carbon. And within Latin America, fossil fuel emissions actually now exceed the amount of carbon being sequestered or absorbed by the rainforests. So if we turn our attention now then to human activity and we think about some of the causes of the changes taking place to the water and carbon cycles. Deforestation is obviously the most significant human activity taking place within the rainforest. This deforestation, if we turn our attention to this graph here, we can see that this deforestation takes place predominantly for agriculture. If we take up the 65 to 70% for cattle ranching, the 20 to 25% for small-scale agriculture, the 5 to 10% for large-scale agriculture, we can see that we're only left with maybe 3 to 4 or 5% taking place for things like logging or other means of deforestation, perhaps for energy production. So agriculture is absolutely the driving force behind this deforestation, either to create space for cattle farming, for pasture land to raise cattle on, or for the planting of other crops like soy. And that's what we can see in this image here. Quite nicely shows that difference on the left-hand side between the rainforest and the right-hand side, which would be a soy field where they are growing soybeans as a crop, often becomes animal feed. Now in the past, Brazil has had a real problem with deforestation, and we can see if we look back to 1995 into the year 2000, 2005, we can see that the majority of Brazil's emissions were coming from land use change and from forestry or deforestation. That has declined in recent years, and we will look at that decline kind of since about the year 2005, 2006. We'll look at why that's happened a little bit later on. But between 2000 and 2007, that's when deforestation in the Amazon was at its peak. And the annual rate of deforestation was around 20,000 square kilometres every year. If we look globally, Brazil is actually the 6th largest polluter. So it ranks 6th out of all the countries in terms of its greenhouse gas emissions. And 75% of those emissions are from deforestation and from land use change. The other complicating factor that we've got in terms of human activity is that global temperatures are also rising, and that climate change has the potential to disrupt the carbon, water cycles and the ecosystems within the rainforest. So if we now start to consider some of the impacts that these changes will have on both the water cycle and on the carbon cycle. We'll start by thinking about the impacts on the water cycle. So one of the issues associated with deforestation is the impact that actually has on rainfall. So because there are fewer trees, there's going to be less transpiration, and in particular fewer particles being released back into the atmosphere through that transpiration. We call these particles, these salts or organic fibres, we call them condensation nuclei, and that's what clouds need in order to form. All water needs tiny little specks of something, tiny little aerosols to condense around, and without those we inhibit the formation of clouds, and therefore we actually find a reduction in the amount of rainfall. The rainforests themselves have a much higher level of humidity, about 20 to 30% higher humidity, and about 5 to 20% more rainfall than the farmland that they end up being replaced with. And it's estimated that future deforestation could actually cause rainfall to decline by up to about 20%, and that's because of a reduction in this transpiration that we mentioned earlier. Now, this reduction in rainfall isn't just limited to the area where the deforestation is taking place. It can have impacts elsewhere, and areas downwind of deforested areas actually can have half the rainfall on average compared with areas that have not been deforested. So these impacts can have consequences beyond the area that has been deforested. Another reason why this rainfall is declining is because any evaporation that is taking place from deforested areas, it usually doesn't form clouds that are large enough to produce large amounts of precipitation. It tends to form small, what we call cumulus clouds, the little fluffy clouds we see, which don't generally bring very much rainfall. A lot of the rainfall within the rainforest is driven by what we call cumulonimbus clouds. They don't form in areas which have been deforested. In the short term, obviously, if those trees have been lost, then extreme rainfall events could lead to flash flooding because there's less interception. There's also less water being held within the soil, about 15% less water held within the soil, and that's because it's more easily eroded, and that in turn is also going to lead to faster rates of runoff. It's going to cause soils to be washed into rivers. So while in the short term deforestation can lead to increases in river discharge, in the long term there's actually an overall reduction in river discharge. Deforestation actually leads to there being less water in the system than there was before. If we think then about how the impacts of human activity affect the carbon cycle, we can understand some of the consequences in terms of temperatures and rates of photosynthesis. So another important difference between forests and farmland is their temperature. So the forests tend to have temperatures of around 24 degrees C compared to 33 degrees C for the pasture land or the farmland that they are replaced with. A common technique to clear areas of rainforest is what we call slash and burn deforestation. This is where trees are felled and then the wood that's left over is burnt. That's a very efficient way of clearing large areas of rainforest. What that does is it leaves lots of obviously carbon on the ground and in the soil, and the rain then washes the ash from those burnt trees into the ground, which actually increases the amount of carbon in the soil, but it also increases the amount of carbon being washed into rivers and then crucially being lost from that system. It's fairly understandable as well that without the trees, the rates of photosynthesis are going to rapidly decline following deforestation. So it's estimated that tropical forests absorb around 2.2 kilograms of carbon for every metre squared of forest, in comparison to only about 0.52 kilograms per metre squared for grassland, pasture land that they might be replaced with. So we're experiencing maybe only a quarter of the amount of photosynthesis that we might normally experience within these environments. Another important difference between rainforest and pasture land is the amount of carbon in the soil. So soils contain about 4 to 9 kilograms of metre squared in the rainforest. That's within the top 50 centimetres of the soil. Whereas pasture land only contains about 1 kilogram for every metre squared. So we can see there a reduction of maybe 4 to 9 times the amount of carbon being stored within the soil. Climate change is obviously not something that is going to go away at any point, and by 2050 it's estimated that temperatures in the Amazon will have increased by 2 to 3 degrees C on average. Now that is going to have knock-on effects in terms of feedback loops, linking to rates of evaporation and drought causing trees to die off, which then further reduces their ability to absorb carbon. If we were to experience a 2 degrees C rise in temperature, that could see about 20 to 40% of the Amazon die off within about a century. If we were to see the upper end of that estimate, a 3 degrees C rise, that could actually kill off between about 75%. And if we were to experience a 4 degrees C rise in temperature, 85% of the Amazon could die off, because it exists within this very narrow, very specific range of temperatures. And when we start to exceed that, the trees can't cope with that increase in temperature. So these are the main impacts on the water and carbon cycles. We're going to see increased temperatures, less carbon being absorbed through photosynthesis, less carbon stored in the soils, and overall lower rates of runoff and discharge as a result of reduced levels of rainfall. Now, although Brazil has been criticised in the past for having very high rates of deforestation, it has actually done remarkably well in reducing those rates of deforestation. If we look at the graph on the right hand side at the top, we can see that over time, from the 1960s through to the sort of early 2000s, there wasn't really much change in the CO2 emissions from land use change, so from deforestation. However, from the early 2000s, we can really see this kind of sharp decline in the amount of carbon being emitted from deforestation. And that links closely with this graph at the bottom, which shows us deforestation rates from 1995 through to 2015. And we can see that following 2004 here, we've got this sharp decline in the amount of deforestation taking place within the Amazon. So overall, the rate of deforestation in Brazil has reduced by about 75% between the year 2000 and the year 2012. They've been very, very successful at reducing the rates of deforestation. And the three things that have really driven this reduction are bans on certain products from deforested areas, better governance in terms of stronger legislation and more prosecutions, and also consumer pressure as well. Lots of campaigns within Brazil putting pressure on all aspects of the supply chain. In 2008, a group of non-government organisations, NGOs within Brazil, they started what was known as the Zero Deforestation Movement, or the Zero Deforestation Campaign. They eventually proposed what became the Amazon Fund. The Amazon Fund is, as the name suggests, a fund of money that's available in order to help reduce these rates of deforestation. One of the important steps within Brazil's journey to reducing deforestation actually focused on the enforcement of existing laws. So there always have been laws in place preventing deforestation, but not necessarily always being heavily enforced. And more prosecutions of people within either the soybean or the beef industry who were either deforesting the land or profiting from activities taking place on deforested land. So the prosecutions really cracked down on sawmills, for example, that were processing timber that came from deforested areas, or slaughterhouses that were processing cattle that had been raised on land that had been deforested illegally. So there were significant prosecutions that took place by the Brazilian government, which really cracked down on this illegal deforestation. Something else that was really significant were the sort of bans, or what we call moratoriums, on the soy and beef industries. Those two industries in particular are the main drivers of deforestation. So what happened was that exporters and soybean processors and slaughterhouses and supermarkets, all of those different people within the supply chain, they basically had to make this commitment that they would only buy beef or soy from land that had been certified as having not been deforested illegally. By making that pledge, it basically took out the market for any products that had been produced on land that had been deforested illegally. This was really, really successful, and a study that was conducted to see how successful this was actually found that only 0.25% of land with soybean crops on it had actually been planted in deforested areas since that moratorium or that boycott or that ban actually began. So this has really, really significantly contributed to the reductions in deforestation. And the campaigns, particularly the zero deforestation movement, they targeted the whole supply chain. They didn't just look at one of these groups. They didn't just look at the exporters or the supermarkets. They looked at every single stage within that supply chain. So the farmers and the processors and the wholesalers, and even the banks funding some of those organisations. And their focus, rather than persuading kind of individual people to change their behaviour, they really, really focused in on the actions of those businesses that were absolutely critical in the supply chain. Another really fundamental step that Brazil took was to increase the amount of protected areas within the Amazon. So the map on the right hand side shows you a map of indigenous lands and protected areas within the Amazon. The Amazon basin is outlined by this black line on the map, and the indigenous reserves, the areas reserved for the sort of native populations of the rainforest, they're indicated in dark blue, and other protected areas are indicated in light blue on this map. So we can see that a huge area of the Amazon is actually designated as a protected region. Establishing and maintaining these protected areas has been really, really effective in reducing the rates of deforestation. So in terms of a figure, just over half of the forest in the Brazilian Amazon is protected in some form, either for indigenous people or as a national park or a special protected area. Those indigenous areas are really important because indigenous people still have the right to use the forest sustainably. Their way of life is very much dependent about living off the forest. So to say to those people that they couldn't use it at all would have been actually quite controversial. What they said was that indigenous people have got the right to use the forest sustainably, and actually most of those indigenous groups have actually chosen to keep almost all of their lands, almost all of that protected area as forest. And the rates of emissions from those areas are about 10 times lower than neighbouring areas. So those indigenous regions, those indigenous protected reserves, have been very, very effective in bringing down the rates of deforestation and the emissions from that deforestation. The final piece in the puzzle really of how Brazil has managed this significant reduction in its rates of deforestation comes down to the support provided by Norway through what's called the RED initiative. Now RED stands for Reducing Emissions from Deforestation and Degradation. It's a UN initiative aiming to tackle deforestation across the globe. And Norway decided that it was going to put forward $1 billion. It was going to put forward this money to the Amazon Fund that we mentioned earlier. That was the fund that was set up by that campaign for zero deforestation. And Norway pledged that they could use that money, what they called results-based financing, or basically pay for performance. This meant that Brazil didn't get any money unless it proved that it had reduced the rates of deforestation. So this wasn't a case of Norway handing over $1 billion to Brazil in the hope that they would reduce deforestation. It was a case of them paying Brazil for proving that they had reduced the deforestation. So there was some incentive for Brazil, but it also meant that there was some reassurances that Norway was going to get something for its money. And to date, about $670 million has actually been paid by Norway to Brazil under this agreement. It's important to understand that Norway doesn't get any right to emit any extra CO2 as a result of any reductions made in Brazil. So it's not to be confused with any kind of carbon offsetting schemes that you may have heard of, whereby one country can pay another country to plant some trees in order for the original country to emit some more carbon dioxide. That doesn't work in this instance. It's all just about Brazil reducing its rates of deforestation. So this money has helped to establish those protected areas and to fund the organisations responsible for tracking and monitoring deforestation and for prosecuting some of the people responsible for the illegal deforestation. To give you an idea of the amount of money, this 617 million, this is equivalent to about $100 every year for every Norwegian citizen. So this is a significant chunk of money that Norway has pledged to reduce deforestation. To give you a comparison, efforts made by the United States under similar initiatives equate to about $1 for every American citizen. So it gives you an idea about the scale that Norway has really assisted Brazil. So that was the picture in the kind of early to middle sort of 2000s. More recently though, things have maybe started to change as a result of some political changes in Brazil, and they've got a new president a couple of years ago, President Bolsonaro. He was very much of the opinion that the Amazon is there to be used, and he was very much on the side of cattle ranchers and farmers who wanted to chop the forest down, convert it to agricultural land, and make some money and some profit from that. And we can see here that the red line on this graph here indicates the rates of deforestation in 2018-19. Black line is 2017-18, so that's the year before. Okay, 2016-17 before that, 2015-16 before that. So we can see that over time, particularly in 2019, in the summer of 2019, the rates of deforestation started to pick up again as a result of some of these changes being made by the president in Brazil. But it does, however, still remain far below the peak of deforestation, which happened in around 2004. So even though it has started to go up slightly in recent years, undoing some of that good work that was done, it's stayed much lower than that peak back in the year 2000, where we had sort of over 20,000 nearly 25,000 square kilometres of forest being lost every year in Brazil. We're still down to around 7 or 8 at the moment. It has gone up in recent years though. If though rates of deforestation had continued at that level that they were in 2005, we would have seen an extra 3.2 billion tonnes of carbon dioxide being put into the atmosphere. That's equivalent to a year's emissions from the entire European Union. So even though things have maybe taken a little bit of a step backwards, we still really must understand that Brazil is arguably still very much a world leader in terms of tackling climate change by reducing deforestation. So in summary then, the water and carbon cycles within the Amazon have quite unique characteristics. Most of the water is cycled within the forest, and only about 30% of that actually reaches the sea. Human activity, which is driven mainly by deforestation for agriculture, that's leading to reduced levels of rainfall, it's leading to the loss of carbon sinks like trees and the soil, and it's leading to increased temperatures, which can in turn trigger droughts in the Amazon. Brazil has been very successful in reducing the rates of deforestation. They've reduced by about 75%, and that's been the result of political pressure, prosecutions, protected areas, and also the support from other countries like Norway. However, more recently, changes in the political agendas in Brazil have started to undo and to reverse some of those significant achievements.